Microsoft just released an AI that can reason through images better than most junior developers, and it's only 15 billion parameters.
Better than developers? How are they measuring that? So we're breaking down the architecture, the benchmarks, and what this means for multimodal AI.
By minute 4, you'll know if this replaces your current stack. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today we're diving into Microsoft/tax/fi-4-vision-15-B/Hugging Face.
Stick around to the end for today's headlines. Let's dive right in.
So Microsoft just dropped something that's making me completely rethink what we know about AI model economics. They've released Phi-4 Reasoning Vision, a 15 billion parameter multimodal model that can see, reason, and interact with computer interfaces. But here's what's wild. It's performing at the level of models 5 to 10 times its size.
Wait, 15 billion parameters? That's actually pretty small compared to what we're seeing from OpenAI and Google, right? GPT-4 is rumored to be over 1 trillion parameters?
Exactly, and that's the revolutionary part. Microsoft is essentially saying, forget the arms race for bigger models. They're proving you can get enterprise-grade performance with a fraction of the computational resources. This isn't just another model release, Alex. This is Microsoft planting a flag and saying the future of AI might not be about who has the biggest data centers.
Okay, but we've heard this David versus Goliath story before with smaller models. What makes Phi-4 different? Because every startup claims their 7B parameter model can compete with GPT-4.
3 things make this different. First, this isn't some startup. It's Microsoft with all their resources and access to OpenAI's research. Second, they've added vision capabilities that can actually understand and interact with computer interfaces. We're talking OCR, GUI understanding, even computer task automation. And third, the benchmarks are honestly shocking.
Define shocking, because I've become pretty numb to benchmark claims at this point.
On mathematical reasoning tasks, Phi-4 is hitting 85% accuracy compared to GPT-4's 92%. But here's the kicker. GPT-4 needs roughly 100 times more compute to get that extra 7%. On vision tasks like chart understanding and document analysis, it's within 3 to 5% of the state-of-the-art models. And for basic coding tasks, it's matching Claude 3.5 Sonnet.
Hold up, you're telling me a 15B parameter model is keeping pace with Claude on coding? That changes everything about deployment costs.
Now you're getting it. Think about what this means for enterprises. Instead of needing a massive GPU cluster to run inference, you could potentially run this on a single A100 or even consumer hardware with quantization. The economics completely flip.
But there's got to be trade-offs, right? You don't get this kind of efficiency for free.
You're absolutely right, and we'll dig into those. The model has some interesting limitations. It's specifically optimized for certain types of reasoning tasks. It's not trying to be a creative writing powerhouse or a general chatbot. Microsoft made very deliberate choices here.
So they're basically saying, let's build the best possible model for actual business use cases, rather than trying to win every benchmark.
Precisely. And here's what's fascinating. They're using a technique they call structured reasoning alignment that's completely different from how OpenAI and Anthropic train their models. Instead of just throwing massive amounts of data at it, they're using synthetic datasets specifically designed to teach chain-of-thought reasoning.
Synthetic data for reasoning? That sounds risky. How do you ensure the model doesn't just memorize patterns?
That's the billion-dollar question, isn't it? Coming up, we'll dig into exactly how they pulled this off, what this structured reasoning alignment actually means, and why it might be the key to making AI economically viable for every company, not just the tech giants. All right, let's get into the technical meat of how Microsoft achieved this efficiency. The key innovation here is something they're calling structured reasoning alignment, combined with a custom vision encoder based on SIGLIP.
SIGLIP? I'm familiar with CLIP for vision language tasks, but what's different about SIGLIP?
So SIGLIP, that's sigmoid loss for language image pre-training, is Google's more efficient alternative to CLIP. Instead of using the traditional contrastive loss that requires comparing every image text pair in a batch, SIGLIP uses a sigmoid loss that lets you train on much larger batches with better efficiency. Microsoft took this and modified it specifically for reasoning tasks.
Interesting. So they're not just bolting on vision capabilities to a language model, they're fundamentally rethinking how vision and language interact for reasoning tasks?
Exactly. The architecture has three main components. First, you've got the vision encoder that processes images at 336 by 336 resolution, deliberately lower than some competitors who use 1024 by 1024 or higher. But here's the clever part. They use adaptive pooling based on image complexity.
Adaptive pooling. How does that work?
So for a simple diagram, the model might pool features aggressively, reducing the token count. But for a complex technical schematic or dense text, it maintains higher resolution features. This dynamic approach means you're not wasting compute on simple images, but you're not losing detail when it matters.
That's actually brilliant. It's like having a variable bitrate encoder for images.
Perfect analogy. The second component is the reasoning engine itself, the 15B parameter transformer. But here's where it gets interesting. Instead of training on general web data like most models, they used what they call reasoning first pre-training.
Which means what exactly? Because everyone claims their training data is special.
They generated millions of synthetic reasoning chains using a combination of formal logic systems, mathematical proofs, and step-by-step problem solving. Think of it like teaching the model to show its work, not just give answers. Every training example includes not just the solution, but the complete reasoning path.
But doesn't that risk the model just memorizing templates? Like step 1, identify the problem. Step 2, break it down.
Great question. They address this by introducing what they call reasoning perturbations during training. Randomly, they'd introduce errors in the reasoning chains and train the model to identify and correct them. It's like teaching someone math by showing them both correct and incorrect solutions.
Oh, that's clever. So the model learns not just to follow patterns, but to actually validate reasoning steps.
Exactly. And the benchmarks bear this out. On the GSM 8K math dataset, Phi-4 scores 91.8%. GPT-4 hits 94.2%. But here's the kicker. When you look at the actual reasoning traces, Phi-4's explanations are often clearer and more step-by-step than GPT-4's.
What about the vision capabilities? You mentioned computer task automation earlier.
This is where it gets really interesting for enterprise use cases. They trained the model on millions of screenshots paired with action sequences. It can look at a GUI, understand what's on screen, and generate commands to interact with it. We're talking about reading spreadsheets, filling out forms, even navigating complex enterprise software.
So theoretically, this could automate a huge chunk of repetitive office work.
In theory, yes. In practice, there are limitations. The model works best with standard UI patterns, buttons, text fields, drop-downs. Custom or unusual interfaces can trip it up, and it's not great at handling dynamic content or animations.
What about accuracy? Because automating computer tasks sounds great until it starts clicking the wrong buttons.
They report 87% accuracy on standard UI tasks, which sounds good, but means 1 in 8 actions might be wrong. For high-stakes operations, you definitely need human oversight. But for things like data entry, report generation, or routine system checks, it's more than good enough.
How does it compare to specialized computer vision models for these tasks?
Here's what's fascinating. It actually outperforms many specialized models because it can reason about context. A pure vision model might correctly identify a button labeled Submit, but Phi-4 understands whether clicking Submit makes sense given the current task context.
So it's not just seeing, it's understanding intent and context.
Exactly. And the efficiency gains are massive. Running inference on Phi-4 costs roughly 1/20th of what it costs to run GPT-4 for similar tasks. For a company processing thousands of documents or automating routine tasks, that's the difference between a viable business case and a non-starter.
But I'm curious about the trade-offs. What are we giving up for this efficiency?
Good instinct. The model struggles with highly creative tasks, nuanced language understanding, and complex multi-step reasoning beyond its training distribution. It's English only currently, and the vision capabilities are limited to static images, no video processing. Stick around, we'll break down exactly when and shouldn't use Phi-4, plus a practical framework for evaluating whether it fits your use case. All right, let's get practical. When should you actually consider Phi-4 over the larger models? I've got a simple framework for you.
Yes, because I'm already thinking about our document processing pipeline. We're currently using GPT-4, and the costs are painful.
Here's your decision matrix. First question, is your task primarily about reasoning, analysis, or structured output rather than creative generation? If yes, Phi-4 is a strong candidate. Second, can you tolerate 5 to 10% lower accuracy for 20x cost savings? Third, do you need to process images or screenshots as part of your workflow?
For us, it's yes, yes, and yes. We're analyzing technical documents and screenshots of system dashboards.
Perfect use case. Here's your implementation checklist. First, run a proof of concept on 100 representative examples. Compare not just accuracy, but also reasoning quality. Sometimes Phi-4 actually gives better explanations than larger models because of its training approach.
What about deployment? Any special considerations?
You can run this on a single A100 40GB for full precision, or even on consumer GPUs with 4-bit quantization. Microsoft provides optimized inference code, but here's a pro tip. Use their custom attention implementation. It's 30% faster than the standard Transformers library.
What about fine-tuning? Can we adapt it to our specific domain?
Yes, but carefully. The model is particularly receptive to few-shot prompting. Often 5 to 10 examples can dramatically improve performance on specialized tasks. For full fine-tuning, stick to LOA or QLOA methods. Full parameter fine-tuning tends to break the reasoning capabilities.
Any gotchas we should watch out for?
3 big ones. First, the model can be overconfident in its reasoning. Always validate critical decisions. Second, it has a context window of 16K tokens, which is smaller than GPT-4's 128K. For long documents, you'll need chunking strategies. Third, while it handles standard UIs well, custom enterprise software might need additional prompt engineering.
What about the competitive landscape? Is Microsoft going to keep investing in this direction?
This is Microsoft's bet on the future of AI. They're essentially saying the path forward isn't infinitely larger models, but smarter, more efficient ones. Expect to see Phi-5 within 6 months, likely with video capabilities and extended context windows.
And the rest of the industry?
Google's already responding. Expect a Gemini Nano update focused on reasoning. Meta will likely release something similar for open source, but Microsoft has a key advantage: access to OpenAI's research, plus their own efficiency innovations. They're playing both sides brilliantly.
So for teams evaluating this right now, what's your concrete advice?
Start with a narrow use case where you're currently using GPT-4 for structured tasks, document analysis, data extraction, or UI automation. Run a week-long pilot comparing costs and accuracy. Pay special attention to reasoning quality, not just final answers. If Phi-4 hits 90% of GPT-4's performance for your use case, the 20x cost savings make it a no-brainer.
The computer automation angle is particularly interesting. Are we talking about replacing RPA tools?
Not replacing, but augmenting. Traditional RPA is brittle. It breaks when UIs change. Phi-4 can adapt because it understands intent, not just pixel positions. Combine them. Use RPA for stable, high-frequency tasks, and Phi-4 for handling exceptions and variations.
This really does change the economics of AI deployment.
Here's my hot take to leave you with. We've been thinking about AI wrong. The race for bigger models is like the megahertz wars in CPUs during the 90s. At some point, efficiency and specialization matter more than raw size. Phi-4 isn't just a smaller model, it's a glimpse of where the entire industry is heading. In 2 years, I predict most enterprise AI workloads will run on sub-50B parameter models that outperform today's giants on specific tasks.
That's a bold prediction, but looking at these benchmarks and cost structures,
The math supports it. When you can get 90% of the performance for 5% of the cost, the economics become irresistible. The question isn't whether this shift will happen, it's how fast enterprises will adapt. And if Microsoft's execution with Phi-4 is any indication, that shift is happening faster than most people realize. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating development from Google today. They've just rolled out Canvas in AI mode to all U.S. users. According to TechCrunch, this feature is now available through Google's AI search, letting anyone organize projects and do research without needing a Gemini subscription.
That's a pretty aggressive move from Google. Canvas has been their answer to Claude's artifacts, right? Making it free to all U.S. users could really shake things up.
Exactly. It's clearly a play to capture more of the AI assistant market, especially with all the drama happening over at OpenAI.
Oh, right. The Defense Department partnership backlash. Futurism is reporting that ChatGPT users are mass canceling subscriptions, calling OpenAI a war machine now.
Sam Altman's apparently in full damage control mode. The irony is that Anthropic's Claude is seeing a surge in popularity because of this. Users are voting with their wallets.
It's interesting how quickly the narrative can shift. OpenAI went from the darling of AI safety to facing this kind of backlash.
Speaking of developments, LangChain just announced their new Langsmith CLI and skills system. This is huge for developers. It lets AI coding agents perform complex tasks like running evaluations and managing datasets directly within the Langsmith ecosystem.
That's smart. They're basically giving AI agents the tools to be more autonomous in development workflows. Could be a game changer for AI-assisted coding.
Now, here's something fascinating from Archive. Researchers are finding that large language models are mimicking human cognitive strategies when searching through semantic memory. They used something called the semantic fluency task to analyze how LLMs explore concepts.
So they're basically discovering that LLMs don't just store information, they navigate it like humans do. That's wild.
Let's talk releases. Hugging Face just dropped Transformers 5.3.0, and it's packed. We're getting Eurobert, a multilingual encoder that handles European languages with sequences up to 8,192 tokens.
And it's not just Eurobert. They've added Vibe Voice ASR, Times FM 2.5, and several other models. Plus, this is marked as a security release, so there are important fixes in there too.
Speaking of security releases, Light LLM just pushed out version 1.81.16. The big news here is they've added Gemini 3.1 Flash Image Preview to their model database and optimized their spend log deletion process.
They're also fixing parallel tool calls handling and preserving server-side tool forwarding. Sounds like they're really focusing on reliability and performance improvements.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.